Hello guys, today let's look at this question from LeetCode. K closest points to the origin. It's actually a medium level question, but it's pretty simple. Given an array of points where points of I is equal to xi, yi represents a point on the xy plane in an integer k, return the k closest points to the origin, 0, 0. The distance between 2 points on the xy plane is the Euclidean distance. Our old formula for calculating distance is what's used. You may return the answer in any order. So here, it's simple. You are given points. So let's say you're given 1, 3, minus 2, 2, and then k is equal to 1. That means you are returning top 1 point. That's closer to the origin than the other one. So you calculate the magnitude of this point from the origin, and then we calculate the magnitude of this point also from the origin. Then after that, we check the one with the least or the smallest magnitude, then we return that point. That means that's the closest point to the origin. So let's visually look at this one. So here you're given this point, which is minus 2, 2. And then you're also given this point, which is 1, 3. So all that you have to do is to remember the origin is always 0, 0. The origin is always 0, 0. So what you have to do is to calculate the distance of minus 2, 2 from the origin. You calculate this distance. And then you also calculate this distance. And then you compare them. The smallest distance corresponds to this point. So we will return minus 2, 2. That's why this is returned. The answer of this is going to be something like 3. The magnitude of 1, 3 is going to be like 3.2 something. And then the magnitude of this is going to be, I think, 2.82 some stuff. So it's very clear that this is there. This has the smallest magnitude. That's why we return that. Let's look at the second example and then dive into the code, or plan the code and then dive into it. So let's see the second example. You're given 3, 3, 5 minus 1, minus 2, 4, and k is equal to 2. That means you are returning just 2 points. That's why here the output is just 2 points. 1, 2. So k is equal to 2. So you are returning just 2 points. But what you have to do is calculate the distance of this 3, 3 from the origin. And then calculate the distance of this 5 minus 1 from the origin. And then calculate the distance of minus 2, 4 from the origin. And then we compare. The one with the smallest distance, that means that one is the closest to the origin. So we add that here to the output. And then we find the next one with the next smallest distance. And then we add that one to this place. And then we have 2 points and we return that. So if the points are, let's say, 20 points, if you were given 20 points, then k is equal to 10. That means you are returning just 10 points. So what you have to do is that you calculate the distance of each of the points given from the origin. And then you see the one with the smallest distance, you add that to your output. Then the one with the next smallest distance, you add that to your output. Then the one with the next smallest distance, you add it to your output. You continue to do that until you have your 10 points. Because if k is equal to 10, until you have your 10 points, then you return all those ones. And then you ignore the others. So, and then also note that the center is always 0, 0. Like the origin is always 0, 0. So let's try to calculate it by hand and see. When we decide to calculate the distance of this from the origin, we are going to do minus 2 minus 0. That's minus 2 minus this 0. And then this 2 minus this 0. So this one, you have to square it. Plus the y coordinate, this 2 minus this 2. This 2 minus this 0, right? It's actually 0. Yeah, that's the origin. So we square that. And then we find the square root of all. Notice how the origin is 0, 0. So you always be subtracting 0, 0 from from it. So you can simplify our calculation to just minus 2 square plus 2 square. So we just square this plus this square, and then take square root of that. So that's exactly what we're going to do for each point. And then after calculating the distance for each point, we need to pair each distance with its point, or we need to pair each point with its distance. So every point and their corresponding distance, we pair them. Then after that, we sort the points according to the distances. So you get to know where each point stands. So let's dive into the code and then see how we're going to do that right now. So how we do that is pretty simple. We're going to use a heap to do the sorting. You know, in a heap, like in a minimum heap, the smallest element resides at the top of the heap. So when we pop that, the next smallest element will bubble to the top of the heap, and then we pop that. The next smallest will bubble to the top again, and then we pop that. So we're going to continue to pop the points like that until we have our top key points, and then we return that. Because the minimum will always come to the top, and then we pop it. And then the next minimum will come to the top, and then we pop it. The next minimum will come to the top, we pop it until we have our top key points, and then we are done. So that's why we are using heap to do the sorting, to make it easier for us. So now we have our heap here. So let's start a for loop for each point in points. So for each one of the points, what do we do for them? For each one of the points, what do we do for it? We calculate its distance, right? So distance is equal to point of 0 square. And I say point of 0 square, you see that here I'm using point without an S, but here the point is with the S. The one with the S means I'm referring to this, and the one without the S means I'm referring to the loop each point that I get from the loop here. So without the S means I'm referring to each single one of them. Each single one of them. So for each single one of them, we also have a list inside it. And the index 0 here is the first one. And then the index 1 is a 3. The 3 has an index of 1. So this square plus point of, I index it 1 and I square it as well. So this is the same as for this point, 1 is this one, the first one, and then 2 refers to that. It has index 1 because inside the point, index 0 and then index 1. So that's it. So this is basically so we are using the square root, right? So you have to find the square root actually. So now we've squared. So now let's find the square root. Math.sqrt of that. So that's so for each point we calculate the distance. Then we put the distance and its points. For each point we put its distance. So this is how we do it. So for each point, so onto the heap. So heap q dot heap pop. Sorry, heap push onto the heap the distance and its corresponding point. This is what I was trying to say. So for each point, we put the point here and then pair it with its distance and then put everything onto the heap. So we do that for all the points. Then the heap will automatically sort all the points for us and we wouldn't have to worry ourselves. The heap will sort everything for us. But what the heap does is it won't sort everything automatically. It will just bring the smallest element to the top. So we pop that. And then the next smallest element in the heap will automatically be bubbled to the top for us. And then we pop it again. Then the next smallest element will come. Then we pop it. So we continue to do that until we get our top K points. And then we return that. So the heap will sort them using their distances. So the point with the smallest distance will come to the top. So when we take that out, the next point with the smallest distance will also come to the top. So we continue to do that until we have our top K. So we are almost done with the code. So right now we've pushed everything onto the heap. So now let's create a variable called top K. And then let's use a list comprehension here. You gotta be smart here. Heap q dot heap pop. Now we are popping from the heap. Remember, the heap contains a tuple, or it contains tuples, where each tuple has a distance, has a point, and its corresponding distance. And inside the tuple, the index 0 is a distance, and index 1 is a point. And we just have to return the points, not the distances. The distances were just to help us sort the points. So index 0, index 1. So now we're going to do this, then write 0 here. That means after we pop, we take the one with index. It's one rather. So we take this index 0 and the point is index 1. So after we pop it, we take index 1. That means we take only the point. So for I in range, okay. But here we don't need to use I. We don't need it actually. So we can just do a hyphen there. And then we're done with the code. And then we just have to return top K. And then that's all. We are literally done. Let me run it here. And it passes the first two tests. So let me submit it. And it works. And it's pretty efficient. So the runtime can be random sometimes. You see? Yeah, so it's pretty efficient. So this is it. So if you just want to know the space and time complexities, for the time complexity, what do? We use a for loop and then we go through each point that signals big O of n plus. Remember, we are using a heap and the height of the heap is log n. So for each element that we put onto the heap, it bubbles it up, or it reshuffles and then bubble the smallest element up. So because of that, each element we pop there will be log n for each. Each element is going to be big O of log n. Each element is going to be this. But remember, we are putting in all the points. You're putting all the points into the heap. You're pushing all of them onto the heap. So we multiply that by n. So it's for each point is going to be log n. But because we have n points, it's going to be n log n. And this is obviously that the n log n dominates the O of n. So this is the run time, the time complexity. And then for space also is on, because we are creating a heap here and then we are popping all the elements and we are pushing all the elements onto the heap. So that is O of n. That is O of n. And remember, when we are reconstructing the top K, in the worst case, K can be equal to number of points. So in that case, K is equal to n. So in the worst case, reconstructing top K or constructing top K also takes big O of n. And that's equal to big O of n, actually. So that's it. So thank you for watching. And if you like it, subscribe or like the channel and also subscribe. It will be so good. Thank you so much.